Bismillahirrahmanirrahim. Today we are going to discuss Physics AS P2 February March 22. Question 1 says a sphere of radius 2.5 millimeter radius falls with terminal velocity. This is really important. Terminal velocity is constant velocity, and when velocity is constant, forces are balanced, they are cancelling each other. It is in equilibrium, object in equilibrium, and diagram is shown. Weight, liquid density, constant velocity downward mentioned. Further, this says three forces act on the moving sphere: the weight of the sphere, and the upthrust. The amount of the upthrust is given, and the viscous drag. The drag force acting on the sphere is given by the value of weight and upthrust are given, but the drag force or the viscous drag, the which is the water or liquid friction here, is given as a formula. Where r is the radius and v is the velocity and k is a constant, state the value of k in SI units. It's 17. So how would you do that? Determine the SI unit of k. First of all, you have to make the k as subject. So r and v multiplying will divide by force, and F comes from the formula ma. The base unit of mass is kg, acceleration is meter per second square, radius is the length, so its unit is meter, and for velocity its unit is meter per second, right? Now simplify, you get the SI unit. In the next part it says use a value of upthrust on the sphere to calculate the density of the liquid. So beta, what is the formula for upthrust? Upthrust is equal to rho GV. Rho is the density of the fluid, right? And we have to calculate the density of the liquid. G gravitational field strength, and V is the volume of the object which is inside. So here it is sphere. For sphere the volume is 4 over 3 pi r cube, right? The upthrust was given, G value we know, and the volume is 4 over 3 pi r cube. We will use the values and find the density, right? The radius here is given to be 2.5 millimeter. You can have a look at here, right? It is in millimeters, so you have to convert it into meters when using the formula, doing the calculation. Okay, now using the values, the upthrust G density, we have to find the value of G is 9.8. the radius is 2.1 in millimeter. Millimeter is 10 raised to the power minus 3, and there was a cube, so it has a cube. Now you can solve. Now the value we have used, the measurement, is this 2.1. it is in two significant figures, so our answer should also be in two significant figures, or it could be one more than that, means three significant figures, right? See part 1. On the sphere in figure 1, draw 3 arrows to show the direction of weight, upthrust and viscous drag. One thing you have to keep in mind, the object was sinking downwards. So when the object is moving downwards, the drag force Fv will be opposite to that. That is why we have taken the upthrust, the drag force, in upward direction. The upthrust is always upward and the weight is downward, right? G. Now next in the second part says determine the magnitude of terminal velocity. So when the velocity is constant, the object is in equilibrium and opposite forces balance out each other. So upward upthrust, drag force was upthrust Fv. They will both will balance the downward force weight which is given like that. right? The value of thrust is given. The drag force is given this formula KRB, where the value of K is 17, radius we have already used, and V is the speed we have to actually calculate. Now is equal to weight is already given, right? So by solving this we can find the value of V. In question number 2, it says water leaves the end of the hose pipe at point P with horizontal velocity 6.6 meter per second as shown in the point P is at height above h above the ground. Water hits the point at point Q. The horizontal distance from P to Q is this. So let me tell you, whenever something, a ball or a bomb or anything which is thrown horizontally from a height, then two formulas I would suggest you should learn. The horizontal distance, you can name it anyway, let's say it is x, is always is equal to u times t. U is this initial velocity, right? And the vertical distance is always equal to half gt square. So these two formula I would suggest you should learn. Now moving onward, it says the air resistance is negligible. Assume the water between P and Q consists of non-interacting droplets of water and that the only force acting is the weight, gravity. Explain briefly why the horizontal component of velocity remains constant as it moves from P to Q. The reason is because there is no horizontal force acting on the object. Only force is weight, which is a vertical force. There is no vertical force acting, there is no horizontal force acting. So the horizontal acceleration is zero. Acceleration is rate of change of velocity. That is why the horizontal acceleration will be zero. So I suggest that next part in say it says find the value of height, which is a vertical distance. So the horizontal, as suggested, you should learn the formula for both horizontal distance. You represent the initial velocity here as v or u, choice is yours, but that is initial velocity. And the vertical distance, as I just said, you should learn it, that is very frequently coming in exam. It is this, but now for your convenience we have done a bit of derivation here as well. How? Let us have a look. If you have to find time, you will use this formula, v will be divided, you get the time. Now we want to find the vertical distance, then we use second equation of motion, ut plus half at square. But the difference is, as we wish to find a vertical distance, so we will take the velocity in the vertical direction, vertical component of velocity, and same is the acceleration will also be taken to be vertical. As initially the object was thrown horizontally perfectly, so there was no vertical component, that was zero. So that makes whole this part to be zero, and vertical acceleration is vertical g, that is gravitational acceleration. Now the value of time we have got was 0.35, this was given here, and the vertical acceleration is this. So now putting the values we can find the velocity to be this. Okay, for the next part, movement of droplet from P to Q, or for the movement of object from P to Q, state explain whether the displacement and the droplet is less or more than. Beta d, the object was actually coming like that, and displacement is direct distance. So displacement is the shortest distance. So the actual path is curved, and displacement is always a straight line. So displacement will be smaller, right? Then it says calculate the magnitude of displacement. So beta, we know this horizontal distance and we know vertical distance, and this displacement is actually exactly like a hypotenuse of a right angle triangle. So displacement, what you wish to find will be base square plus perpendicular square and we know the value of x and h we have just calculated, and then use this formula, right? G. In question number 3, a jet of water hits a vertical wall as it is shown with velocity is given here, density is given, cross section area is given, and uh, area again mentioned here. So show that over a time of 1.6 seconds, the mass of the water hitting the wall is this. We have to show this. We are given density. So how would we find the mass? The mass is equal to density times volume. Density is mass over volume, so mass is density times volume. The density is given, but how would we find volume? We are given the cross section area. So, and you can see that it all almost looks like a cylinder, the water jet, right? So for a cylinder, the volume is cross section area multiplied by its length. So area is given. How would we find the length? We are not given the length directly, but length actually is the distance, and we are given the speed. So distance is speed multiplied by time. The speed is this, and the time is given 1.6 second. So we put the values. Density, area is given, right? The length is speed times the time. You put the values and you will get your answer. In the part B, it says decrease in the horizontal momentum, change in momentum. The basic formula for change in momentum is equal to m into v minus u. As it said in the question, the water stops after hitting, so v is 0, and the initial velocity was 5, and the mass we just calculated in the last part was 1.2. So we use the formula of impulse or change in momentum, that is m into v minus u. Now putting the values, the answer is 6. The negative 6. Negative shows that it is a decrease. So when you are writing the value of decrease, then you don't have to mention, because decrease also always means the negative value. You don't have to write negative here, right? You don't need to write, because it is always a decrease. Then it says find the magnitude of the force. So force is equal to change in momentum over time. We know the change in momentum, and the time was already mentioned in the previous part in the statement, and put the values, the force in the Newton we will get. So in second part, the statement says the magnitude of horizontal force exerted on the water by the wall. So this was the force on the water by the wall. In C part, state and explain the magnitude of horizontal force on the wall by the water. So beta, according to Newton's third law, every two objects apply equal and opposite forces on each other. So if this force is 3.7 Newton, and the negative sign, actually the momentum was negative, that was showing it was towards the opposite or left side. So the water will apply the same force, 3.75 Newton, on the wall, but its direction will be opposite towards the right. Now next part is quite easy. Calculate the pressure exerted on the wall. The pressure is force over area. So force we calculated 3.75, area is given. Divide, you get the answer in. They are in same base units, standard units, no need to change anything. You get the pressure in Pascal. In the next part is so the child is coming downwards, and from point X to Y, from at X it was at rest. Average resistive force is 75. That is going to be friction for solid surfaces, and the kinetic energy of the child at Y is 300. That is very important. I have actually habit of underlining or highlighting all the important data. You should also do that when you are solving or answering a question. The kinetic energy is 300. Decrease in gravitational potential energy is 3200. Determine the kinetic energy of when resistive force 76, that is 300, and divided by kinetic energy of the child if there is no resistive force. When there is no resistive force, then the decrease in gravitational potential energy would have been equal to the kinetic energy, right? Loss in gravitational potential energy is equal to gain in kinetic energy. So if there was no resistive force, the kinetic energy would have been equal to, the gain in kinetic energy would have been equal to the loss in gravitational potential, that is 3200 given. So we use a value, and with this force we know the already it is shown here that the 300 was kinetic energy with the when the resistive force was acting. So basically putting the values and you solve, you get the answer. Then next is use the answer to calculate the ratio of speed of y with resistive force with speed of y without resistive force. As we just calculated the ratio of kinetic energy, the kinetic energy is equal to half mv square. So we use the formula on both sides for half mv square. One, when there was resistive force, we say that force Vr. I have tried to written R here, that is showing Vy, sorry. That is when there is a resistive force. And this is the kinetic energy when there is no resistive force. As we actually calculated in simplifying, this is equal to 3 over 32, or you can just right away use this value 0.094. The ratio of kinetic energy is 3 over 32, or you can use the same value here of 0.094. That is equal to the ratio of kinetic energy. The kinetic energy is half mv square. The first one is with resistive force, that is Vy. You can name it Vr, V1 to just make it different from when there is no resistive force. So both in both sides the half m will be cancelled, and we get the ratio of v squares over v square is equal to Vy square over v square is equal to 3 over 332. We wish to find the ratio of speed, not their squares. So we will take the square root of both the sides, and this will we will get, and this will be your answer, right? In the next part it says calculate the length of the slide from x to y. So whenever something is falling, we use the formula that the loss in gravitational potential energy is equal to gain in kinetic energy. But it is the formula is just equal to this one when there is no resistive force. But if there is resistive force, one thing we add, that is on the gain side, whether the object is falling or rising, which type of energy is gaining, increasing. On that side there will be work done against resistive force is also done, that is equal to the heat produced, right? So work done against resistive force will be added. As we know, the loss in gravitational potential energy was this, the kinetic energy at that point, because the object started from rest. So at y the kinetic energy was 300, it was told in the statement. The work done against resistive force is equal to resistive force, that was 76, multiplied by the distance from x to y. We can say it dl, choice is yours. I have written as l, and this is what you had to find. Now you can just make simple calculation to find the value of l. Then it says at the end y of the slide, the child is brought to rest. Brought to rest means all this kinetic energy is stopped and is converted into other forms of energy. And what is this? A spring is shown, spring is compressed. So the kinetic energy will convert into the energy of the spring, that is elastic potential energy. And given elastic potential energy is 140 joule. So it says calculate the maximum compression of the spring, and the formula for the elastic potential, there are two formulas, one is half Fe and one half Ke square. As we are given the constant, spring constant here 63, so we will use the formula of spring constants. This formula we are going to prefer, right? So elastic potential energy is given 140, that will be equal to half Ke square, the K is 63, and compression E extension or change in length is called E, and this is what we have to find. Now you can calculate it to be this. It is in standard units, it is in meters. In next part it says find the percentage efficiency of the transfer of kinetic energy. When the child reaches the board or the point Y, its kinetic energy was this, and the elastic potential energy stored in the spring was this. So we will divide the energy stored in the spring by the total energy when it reached there by 300. This is efficiency. Multiply by 100, you get the answer to be this. The percentage efficiency can is written up to one decimal place. You can round it off as well. In the next part says the maximum compression of spring is this. Sketch a graph to show the variation of the elastic potential energy. Now, the elastic potential energy has two formulas, half Fe and half Ke square. X is extension. As we know, the elastic potential energy is half Ke square, means the elastic potential energy has a relation of with E square directly proportional to square. And when there is a square, we get a parabolic, a curved graph. When there is power 1, we get a straight line. So square always gives you an upward graph, a curved graph, parabolic, positive parabolic. If it was to be on both sides, it would have been like that. But for only positive side, it will be like this, right? Question 5. Say the condition required for stationary wave. The stationary wave is formed when two waves or having same frequency interact each other, but they should be traveling in opposite direction, right? State the phase difference between any two particles in a stationary wave between two adjacent nodes. This is to learn. All the points between two nodes, they are always in phase, and when they are in phase means there is no difference between them. So the phase difference is 0. If you try to be more technical sometime, 0 and 360 degree are equal. So if you write 360, it will not be wrong, but it is 0 phase difference. Don't prefer 360. Now, a motorcycle is traveling at 13 meter per second. So this is the speed of source, V as we call. And the motorcycle sees a pedestrian standing, and then he operates a horn. Horn is a sound. Sound has a speed is 334 given here, and the frequency, the sound at a frequency. This is the pedestrian hears this frequency. This is called the observed frequency. And when the person is getting closer to the motorcycle is getting closer to the observer, so this is going to be blue shift. When the source is getting closer to the observer, and for the blue shift we use the formula this with a negative sign in the denominator. If it would have been red shift, then it would have been positive sign here, right? So for the blue shift, the formula is the actual speed of the wave over actual speed of the wave minus the speed of the source, which is given there, times the actual frequency. And we have actually to find the actual frequency. This is what we have to find. Now putting the values, and then you can calculate the answer. Next part says the motorcycle rides passes the stationary pedestrian, then moves directly away from us. As the rider moves away, he operates for no second. The pedestrian now hears sound at increasing frequency. First of all, when the pedestrian is moving away, then it involves the red shift. So it has passed. The red shift means the frequency is decreasing. But you have to keep in mind, the frequency will always be less than the actual. But if the speed is of the source is increasing, then according to this formula, the frequency observed will be decreasing. It means object is right, it is inversely proportional to this. So if the speed is decreasing mathematically. You can say it is in the denominator na vs, so it has an inverse relation. It means whatever happens to the speed of source, the opposite happens to the frequency. As it says, the frequency will be increasing, so this means the speed will be decreasing. So it means the motorcyclist will be decelerating. I'm repeating, if you see the formula of redshift, the vs and v, the vs is in denominator, and there is an inverse relation between vs and the frequency. So when it says the frequency is increasing, it means the speed is decreasing, the motorcyclist is decelerating. The next is polarization, a vertically polarized manner, monochromatic light. Monochromatic light is of one same frequency, vertically polarized. This is very important one. That is why I have highlighted it or made a line above it, right? Vertically polarized filter is passing through, and there is a polarized filter which is rotated to some angle 20 degree. The polarized filter with its transmission axis at an angle of 20 degree to the vertical, as it's shown, it has a 20 degree angle right here. To the incident light was I naught, that is actual, the transmitted light is IT. By considering, calculate the ratio. So beta G, ratio of amplitude, this is a really important question actually. This is one of the important question in this paper. There is always a part which makes difference between a good and very good student. It is one of those. So when it says to find the relation between the amplitude, so the amplitude, for Meluso's law we know the formula which is involving the intensities. So we can find the ratio of intensities, the transmitted and I naught in actual. But as we know, the intensity is also proportional to the square of amplitude, right? So the intensity I1 I2 is equal to A1 square over A2 square, where A is amplitude, I is intensities. So now here I1 is over initial intensity IT, and I2 over is total intensity. We can write it any manner. So that will be equal to the amplitude, transmitted amplitude square over actual amplitude square. So as we have to find the ratio of amplitude, note this square, we will take the square root of both sides here, right? So in other words, we get the ratio of amplitude is equal to square root of the ratio of intensities. So we can do, if the intensity is proportional to square of amplitude, in other words, the amplitude is proportional to the square root of intensity. So this is what we have written here. So IT over I naught, we from Meluso's law, IT is equal to I naught is equal into cos square. So IT over I naught will be equal to square of cosine of angle. So here angle is 20 degree, right? So we will write IT over I naught, substitute it as square of cosine. The square will be cancelled by the square roots. We will get only cosine of 20 degree, and that will be your answer, right? This is again the good part, and that is important. It is of only of 1 mark. The filter is now rotated. Look at the statement about the direction of beam starting position. The direction rotates such that the angle of transmission is uh, axis to the vertical initially increased. Means you will keep moving from the vertically, it will increase. So it means you will keep moving it clockwise, right? You will keep moving it away from the vertical. Vertical is the central line with which the 20 degrees touching, right? So you will keep moving it clockwise, And it says calculate the minimum angle through which the filter must be rotated so the intensity of the transmitted light returns to the value that it had when the filter returns to the value. That is most important part here. It returns to the value that it had, yani same value, right, as its starting position. Starting position was which was given in the diagram. So the difference, the formula is this: the I node is fixed and we need I to be same as well. We need it to be stay the same. So it means the only thing changing could be this. If we want all the values to be same, then this should be same. And when the cos is same, and so there is a bit of trigonometry involved. As we know, the we have a value of cos theta, and if we subtract the value of the angle of cosine from 180 and take the cosine of that, the answer will be same but the sign will be different. If this one is negative, this one is positive. If this one is negative, this one is positive, the sign is different. But as in the formula, the square is involved. If we take the square of both sides, the answer of both sides will be positive and equal, exactly equal. So beta, so when the angle is equal, when the cos is equal, when the angle of cos is subtracting from the 180 degree. So as we were already knowing, the angle was initial 20 degree, right? So 180 20 will be 160 degree. But now it says you have to tell the minimum angle through which the filter should rotate from the starting position. As starting position, it was already at 20 degree, and you have to make the total angle to be 160 degree. It means what you have moved is, it was already at 20 degree now, so 160 minus 20 degree, 140 will be your answer, right? Okay, wait, the question number 6. 8-volt battery, a resistor wire, the power dissipated is 36 watt is given. The current in the resistance, it says calculate. Beta, when power is given and voltage is given, so we can use formula, the most important, most common formula power, P is equal to VI. P is 36 watt and V is 8, and divide, you get the current in amperes. Don't forget the unit. Number 2, the number of free electrons that pass through the resistance wire in a time of 50 seconds. So beta, as we know, the formula for current is I is equal to Q over T. And when we say the current is flowing, so it is, we have two formulas for current. The one is I is equal to NaVe. The small n is number of free electron density. So no number of free electron density is being asked, so we are not going to use this formula. Then we will go back to this formula again. I is equal to Q over T. The Q is charge, and what is the total charge? As we buy some chocolates from a store and we have to find the total cost, we will multiply the number of chocolate with the cost of one chocolate. Similarly, the total charge is always equal to the number of electron multiplied by the charge of one electron, that is elementary charge. So this formula you need to remember, that has come many a times. So we are going to use this formula. The current we have just calculated, time it has already given here, and the charge of one electron, the elementary charge, we should learn it, although it is given in the data, the first 2 pages. Then you can calculate the number of electrons. Now the resistance V is equal to IR. The resistance will be equal to V over I. The voltage 8, current we calculated was 4.5. It's quite easy. The next part, the metal of resistance wire has the resistivity cross section area determine the length, and the formula is resistance is equal to rho L over A. So if you make the L as subject, length we have to find, resistance is given, area is given, and the only point here is actually this area. The area is given in millimeter square. Beta G, milli means, when we say the millimeter square, it is not the square of only meter, it is square of milli. Milli means 10 raised to power 3. So it will be square of millimeter square means it will be square of milli as well. So 10 raised to power minus 3 square will be 10 raised to power minus 6. So this is the only point where student can make mistake. So you will not write area as only 0.25, you will write it as 0.25 10 raised to power minus 6. All the other values are given in standard units, no need to change any unit, and you get your answer. G beta, the next part C says the circuit is modified by replacing the original resistance wire with the second resistance. The second wire has greater diameter, area is greater, right, than the original. There are no other differences, means material, length, they remain same, and the material is same, the resistivity is same, right? The resistivity is same, and by reference to resistance, state and explain. Length will be same as well. It's as I said, there is no other change, only the diameter is changed. State and explain whether the power dissipated by the wire is more or less. First of all, when there will be larger diameter, it means the area will be larger. And area is inversely proportional to the resistance. Means the resistance will be smaller. And when there will be lesser resistance, so only thing in this circuit we were given the formula of voltage. We know the formula for power VI I square R V square R. So as we are given the formula for voltage only, right? And when wire is changed, the current is changed. We are not sure about current. We are only sure about the voltage is the same. And the other thing, we are given hint about the diameter, which gives us the hint about the resistance. So the formula we need to use here will be only this formula, because we know the voltage and resistance. And as resistance here is inversely proportional to the power, so it tells when the resistance will be lowered, the power will be increased, the more power will be dissipated. There is inverse relation between. Let me tell you, there are three formulas for the power, but why we can only use this one here is we only know about the voltage is fixed, that is of 8 volt. The current will be changed when the resistance will be changed. So we know the resistance is changed and the voltage is fixed, so we only know about voltage and resistance. So that is why we use this formula, right? So what is the answer? The resistance is decreased due to larger area. The resistance is increased. There is inverse relation between the with the power. So the power will be increased. Better here, it may modifies the circuit, and both there are two batteries now 8 volt uh, connected in parallel. In parallel, the voltage stays the same. So when two batteries are connected in parallel, it means again the total voltage will remain the same, 8 volt. The total voltage is not going to change. So it says by reference to current in this state and explain whether the addition of second battery causes the power in the original. So as we just discussed, the formula for the power is P square. P is equal to V square over R. As the voltage stays the same and the resistance of the wire stays the same, so there is no going to be no change into the power, right? G, in the next part says the nucleus decays by positive beta particle, a different nucleus is formed by the decay. State the name of the another lepton. Beta, here I have mentioned the equation. When positive beta decays, the upper number stays the same, the low number is decreased by 1 for positive beta. For negative beta, it increases by 1, the proton number, but for positive, it decreases by 1. And with the positive beta, a neutrino is produced. Neutrino has a symbol of V, a tilted symbol of V, that is not straight one, right? So the first answer, the lepton produced, is neutrino. Then it says the number of nuclear number of the product. As we said, the nuclear number stays the same, so it will be same. And proton number decreases by 1. From 11 it turns to 10. The equation is going to help you. So you should learn the equation of alpha, beta, and gamma decays. Next is the quark composition is changed during this. So describe the change. So beta, you have to learn in positive beta, the actually proton is changing into neutron. The proton is made up of two up and one down quark. Neutron is made up of one up and two down quark. So uh, the up and down quark pair and up and down quark pair is common in both. The difference is there is one up, and if you have to convert proton into neutron, that up quark needs to be converted into a down quark. So this is the answer. So the up quark of the proton transforms into down quark to form a neutron. Now it says the baryons the baryon consists of quarks that are the same flavor. The same flavor. The charge on the baryon is 2 times E. So it says calculate the in terms of E the charge of each. So in baryon it is made up of 3 quarks, and it says all are of 3 types. It means the charge of 1. How would you get? You will just divide the total charge by 3, right? So you get the charge on 1. It is similar like if you had known the cost of 3 chocolates, you divide the cost total cost by 3, you will get the cost of 1 chocolate, right? Now state the possible flavor. So this is the charge now which we get. The positive 2 over 3 we get on up quark, top quark or charm quark, and negative will be their anti. So it will be an anti up quark. All 3 will be anti up. This is the answer. Or you can write it says they were of same flavor. So all 3 will be anti up or anti top or anti charm. All 3 are correct, but one at a time you have to tell. Jazakallah.